Good morning, good afternoon, depends on where you are. Welcome to participate in the new webinar. Today's webinar is called IoT Fundamentals, Everything About LoRaWAN. I'm your present Jessica from the marketing department of MileSite. Well, through the last webinar, I think we have got familiar about LoRa and how LoRa works. So today, let's talk about something of LoRaWAN, its functionality, the LoRaWAN's security aspects, and that are so important to know. And finally, let's check some end devices and gateways and how to get started with MileSite products. What is LoRaWAN? LoRaWAN and LoRa, they are not synonymous, okay? LoRaWAN is the Media Access Control Layer Protocol, the MAC layer protocol, on the top of the physical layer. So what protocol to be used in communication protocol and the system architecture? And the data, the payload encryption, decryption, those kind of works, that belongs to LoRaWAN. And let's review this picture again, because yesterday some audience are so confused about the license-free spectrum. Since LoRa is a radio, is not a protocol, so it must work within a certain frequency range. The radio spectrum is distributed, is authorized by local government, and the license, you need to pay for the license for specific functions. Well, for example, here, the cellular phones, they have several reserved frequency bands around 900 MHz and 1800 MHz. So the users will need to pay for use within this kind of bands. But however, there are some specific bands that are available for low power use and license-free. So the 2.4 GHz is a global band that allowed for unlicensed operations. So Wi-Fi and Bluetooth, they can work together in this band. And LoRa is designed to work in license-free band legally in different regions, in different countries. So that is the license-free spectrum. That is license-free band. So there are frequency plans. For example, here in the United States, the band is called US 915. It goes roughly from 902 MHz to 928 MHz. And US 915 is a band where there is a fixed number of channels. So you can find 64 channels for uplink that are 125 kHz in the bandwidth. And you can find 8 channels that are high-speed channels, channels with 500 MHz. And with 500 kHz, again, for the downlink message, for the downlink communication between the network and end devices. So there is a channel defined, and that's the region parameters that are defined by the LoRa Alliance. And you may ask what's the situation in the European market? Okay, well, LoRa in Europe is a little different. It uses about 600, the EU 668 that megahertz ISM bands. That defines about 10 channels. 10 channels from 863 to 870. Okay. And 8 of those 10 channels, they are multi-data rate. So you can find the 8 channels with 250 kbps to 5.5 kbps. And there are about one fixed channel with 11 kbps and another one fixed channel with 50 kbps. So, well, some audience are curious, since there are so many channels in the United States, in the US market. So it means, can we build up the gateway, LoRaWAN gateway, have a more capacity? Okay, can we build up a bigger network in the US? Well, the answer is no, because the LoRaWAN gateways is limited. So you can find like only support 8 channels or 16 channels. And that means simultaneous communication, okay, with the sensor node. So, and besides that fixed channel quantity, the number of fixed channels in the gateway, you have to respect the legal regulations. I mean, the duty cycle and the wear time. I think you still remember that about the duty cycle, about 0.1% to maximum 10% in Europe, and about the 400 milliseconds per channel, okay, for each communication in the US market. And what's really important in LoRaWAN is the device classes. And there are about 3 classes. You have the Class A, Class B, and Class C. Class A, it means all LoRaWAN-based devices, sensors, they can support this type of class, Class A. So all Class A stands for ALLO. And Class A means that any device can initiate a transmission, and any device can send uplink message at any time. So this is typically used by devices like manhole covers or trash can monitoring. They just work, they can sleep at most of time and several hours or even a few days to send a message. So that's very power saving for this kind of devices or this kind of applications. Class A. And Class B is a beaconing. Beacon is sent by the network on a fixed interval, and the end device can pick up this beacon and wake up to receive a downlink message. So Class B devices, they are in deep sleep, but they wake up on a time interval to listen to the message from the network. So Class B is not so powerful, it's not so power saving as Class A, but it allows the network to send a message to the end device at a fixed time interval. So even if there's a latency, there's a downlink message delay for about a few minutes. And finally, you have the Class C. Class C, it stands for the continuous downlink. It means that the end device is continuously listening for the downlink messages. And this allows the network to send a message to the end device at any time. So it's opposite. This Class C, these types of devices, they just work, they don't sleep, so they use more power, and they are often mains powered. And Class C usually works with devices like switch, like street lights with power source. So you can turn on and turn off those kind of street lights at any moment you want. So which type do you need? I think is the trade-off between the battery lifetime and the downlink message latency, okay? So that you need to make balance. So device classes, this is how it works. For the Class A device, each device sends an uplink message to the gateway and is always followed up by 2 short receive windows. That's what you can see here in the yellow color. That's the first receive window, and it always occurs about 1 second after the uplink message. And the second window, the second receive window here in the blue color, it always occurs about 1 second after the first receive window. Okay, so Class A mode is mandatory, but it can receive a downlink message only after it sends a uplink message. So the downlink message, it seems like a by the way work that only after the end device sends an uplink message. So in that case, you have a chance to take back the downlink messages. And with Class B, here you can find the receive window. The second receive window comes back regularly. Okay, so it allows the network to send a downlink message on an interval. So the Class B has the possibility to not wait for the end device to start communication. So end device can receive the comments, end device can receive the message from the network at regularly to receive that. So it's, for example, like every 2 minutes to get the downlink message from the network, from the gateway. And with Class C, the windows, it keep opening. Okay, here you can see, you can send a message to the end device at any moment you want. So the network, he can send comments back at any minute he wants. So as a result, Class C is the mode using the most resources, but there's almost no downlink message latency. So for example here, if you are using our mile-side IoT cloud for the smart irrigation, and if you set up Class A, it means if you want to start the valve controller, the watering equipment, okay, you need to wait about 20 or 30 minutes until the next time the end device send a data, send a payload. But with Class C, there's almost no delay. So you can right now open or close the valve controller for watering from the mile-side IoT cloud. And in mile-side, currently our gateways cannot support Class B, but just for your information, we are in developing it. Our engineering are working to support Class B in our gateways. So at that time, we can easily to realize the regularly watering or regularly irrigation from our mile-side IoT cloud. For example, you can set up every 2 hours to watering the farmland, to watering your field. Well, if you follow up some recommendations, why end devices, they will work as efficient as possible. First is about the payload size. It should be as small as possible. In a very low data rate, I mean a high spreading factor, the limit is typically about 51 bytes. And if you use a higher data rate, I mean a lower spreading factor, the limit goes up to 241 bytes. So this means that you should not send any JSON or XML message, but instead encode your data as a binary data, and the network server will transfer it into a JSON object that application server can understand. And that's why we cannot realize such as the voice communication, the phone communication through the LoRaWAN network. And as a modern qualified manufacturer, mile-side, we also help our customer to respect the different regulations in different regions without performing inference. So in the EU market, Europe market, there is a duty cycle. And in the US, there are dwell time restrictions. So all our end devices, these restrictions are enabled and fixed. And end users, you are not allowed to change these settings because we need to respect these legal requirements. And the data rate should be as fast as possible to minimize your airtime. Spreading factor 7, the bandwidth 125 kilohertz is usually a very good place to start because it consumes the least power and airtime. If you need more range, you can slowly increase the spreading factor and the data rate until you have enough. So it can up to 5.5 kilobits I mean 5.5 kbps on that typical bandwidth. And also you can enable adaptive data rate ADR mechanism. The network will able to automatically optimize your data rate and instruct end device to change the spreading factor. And most of the time, the 90% of the traffic is uplink from the end device towards to the network, and downlink is typically limited. Now we can talk about something about the security in LoRaWAN, since many customers ask me if it's secure, if it's safe to send data over the free license spectrum. I think this question is similar like whether it's safe to use the car on the road, whether it's secure to walk on the road, because it totally depends on how you drive the car, how you work on the road, and whether you can respect the traffic regulations. And first, I want to emphasize the physical layer. LoRa does not provide any security here. So you can purchase any device like the sensors and the gateway with a LoRa chipset to build up a network for the long-range communication. But it doesn't provide any security mechanism. So that's why we need LoRaWAN here. Okay. And LoRaWAN, there are three pillars of security. So LoRaWAN provides the security from three very important aspects. First is the authenticity and integrity and confidentiality. And authenticity, that means you can understand, you can know with which device, with which end device that you are communicating. So that device is authenticated by your network. And integrity means during the data transmission, no one can tamper with the data. No one can modify that data. So you know exactly who sent that message, and that message hasn't been changed, hasn't been modified by any intermediate party. And finally, confidentiality. It means that you can encrypt the data on the application layer, and once the data is encrypted and the network cannot see what payload is. So how does that work? Well, there are two different layers. So LoRaWAN provides the security on two different layers, as you can see here in this picture. There are two keys. One is for the network security. That is the network session key. To make sure, it means no man is nobody in the middle, or nobody can modify the message. And this key uses AES 128 base key to generate a mode for the message integrity. And another is for the end-to-end payload encryption. So here you can find application session key. It's also used the AES 128 base key. It's the industrial standards for securing the communication. So both keys are the AES 128 base key. So we have the network session key and we have the application session key. So now, in the network layer, security is provided by the network session key, and in the application layer, the security is provided by the application session key. And they have different functions here. The authenticity and integrity of the message is guaranteed by the network session key, and the message confidentiality is by the application session key. So there are two static keys which are stored in the device and in the gateway. So I guess the security is pretty good. So I'm very sure about that. The security is pretty good. And now we know LoRaWAN session is actually contains two different sessions. The end device needs to unlock the communication with the network server with a key, and after that unlock the communication with the application server with another key. So the network session, between the end device and network server, that contains a device address. So here you can find DEVADDR. That means device address. That's a 4-byte address that generated or issued by the network server. And there is a network session key. There are frame counters. Frame counters is used to count the number of received packets. And also you can find some mark state. Mark state, it means to tell the gate or to tell the end device to change the channel, to change the data rate, to change the spreading factor, to change the port. So that means mark state command. And the application session is secured by the application session key for the payload encryption and decryption. Okay, that happens between the end device and application server. And you can find there are frame counters as well. So during a session, the session keys don't change, and the frame counters, they are always increased and never reused. So, and the device, the end device, they can reset the session. It means they can rejoin the network. And that's the difference between two activation mode. So you can find there are two different ways for the end devices to join a network. I think we are all familiar about their name. First is the OTAA. So when end device join a network, that's being called establish a LoRaWAN session. So if it's a dynamically join, so every time it sends, the end device needs to send a join request, then we call it over-the-air activation or OTAA. For example, suppose an end device is not in a network yet. He should send a join request that asks him for join online. And any network server can respond to that end device. And network server must make some security operations to allow that join. So every time when the end device joins a network, there is a new set of security keys, including a new network session key and a new application session key. So that's the OTAA join procedure. And another way is the hard-coded session. We call it ABP, activation by personalization. So there's no joint procedure as OTAA because the end device get a pre-programmed, like the device address, the session keys, the network session keys and application session keys, they are pre-programmed into the end device already. So when the end device powered on, it will join a network automatically. So ABP is more efficient because you don't need to get approval. You don't need to wait for the join accept. But it's not so secure as OTAA. If you want to hand over, if you want to change from one network to another LoRaWAN network, in that case, you may facing some troubles by using ABP mode. Okay, let's spend a little bit of time to better understand the OTAA process and ABP process. In OTAA, you can find the end device is stored with device EUI, app EUI, and app key. So the device EUI, app EUI, there are 64-bit unique ID in the world, and the app key is used to generate the session keys finally. The the network session key and application session key. So watch out here, the sneaky S in the middle. Otherwise, you will get confused. So in order to activate, in order to join the network, the end device sends a join request. And that join request including this device UI, app EUI, and app key, as well as a random device nonce. Send the request containing those very important information to the gateway. And the gateway is the dumb packet forwarder here. He just totally forward the packet to the network server and without any processing on it. And network server receives the request, and he will double check this. He will validate the app UI with entity with somebody else. Okay. If everything is fine, if everything is okay, the network server will send a response, including the join accept message to the gateway. And in that join accept message, it contains a network ID. Okay, is the pointer to help the end device to find the right network server, and also contains a device address. That's a device address is initiated by network server, and an app nonce, as well as some other network settings like the downlink settings and the receive delay, and some other optional settings like the channel frequency list. And this join accept message will be passed by the gateway totally to the end device. And once the end device receives the packets, he will store the net ID, the device address, and take use of the app nonce to generate the network session key and application session key. So in that case, it means the end device joined the network successfully, and he can start to send uplink message. So end device, here you need to be mindful. This net ID, device address, and app nonce will be stored by the end device. So every time when the end device needs to send a message, he will always use this kind of security keys. And in APP mode, in the activation by personalization mode, end device does not need a device UI, he does not need app EUI, neither the app key, okay? Instead, the session keys, the application session key and network session key, and the device address that are pre-programmed into the device. And the device is pre-registered onto a specific network in advance. So here it means before the end device out of factory, those kind of set keys and device address is already pre-stored, pre-programmed into the end device. For example, in the memory part, in the memory component of a device. And when the end device wants to send a communication, well, he just using the session keys without having to use the join procedure as the OTAA. So here we can find it's much more quickly, it's much more efficient by using APP. And you may ask, which one is safer? Well, I think it's highly recommended to use the over-the-air activation, because there's a new network session key and application session key for every time the device joins the network. But in APP mode, it's always the same. The end device always uses the same session keys. And over the activation, it allows the rekeying. It means no matter the firmware upgrading or is the LoRaWAN version upgrading, you can instruct the end device to join the network again. But through APP here, the session keys, they are stored in the end device, and they never change it. And if you want to switch from one network to another one, for example, if it's a LoRaWAN-based GPS tracker that moving from one country to another country, okay, then the end device just send a request, join request again to go through the join procedure. But in ABP mode, you can also do that, of course, but you need to manually copy all those session keys to different networks. And you cannot require other networks, the previous networks, to delete or to forget your pre-stored keys. So we strongly recommend to use OTAA mode. And LoRaWAN is secure by designing, but the implementation matters as well. So LoRaWAN security is an end-to-end security. You can see here in the red color. Well, it is the application session key between the end device and the application server. And in light blue here is the security session key. The network session key that encoding between the end device and network server here. And gateway here is just designed for the internet connection. So you can get IP address. If you want to have a secure connection with your gateway through the gateway to the network server. Well, some industrial standards are available here, such as the TLS certificate, API keys, firewall, or the IPsec protocols. So you can build up a very secure channel to communicate with the network server. And the same goes obviously from the network server to the application server over the internet. And by the way, if you use our mild-side gateway, for example, the network server is always embedded into the gateway hardware. So you can communicate with the final application server through the Ethernet port, through the wired cable, or through the wireless, such as the cellular network, 3G or 4G or even 5G. And a few things on primary. And there are some privacy considerations. So LoRaWAN is a protocol. It uses unlicensed spectrum. So anyone can set up a LoRaWAN gateway. And he can start receiving the LoRaWAN traffic. So even though the payload is encrypted, so there's a bunch of metadata that is the public information. So as an application developer and LoRaWAN developer, we need to be mindful of that. And when the end device joins a network, for example, he sends the join EUI, and that's the pointer to the join server, which is the component that generates this kind of session keys. And the join server sends the device EUI, that's the unique identifier and of the end device, and that just flies through the air, on the air, that's fine. As soon as the end device has a session established, he starts to send a message that contains a device address, and there are frame counters, there are ports that are being used, and the length of the payload, the length of the frame, so that's all public information. So there are some recommendations on how to make sure that hackers, even though they can read the payload, but they can still not understand what the payload that could potentially meaning, or which device it is, the message sends from, or who is the real owner of that device. So that's very important to keep in mind. So when we setting up our end devices, we need to program them with the join EUI and app EUI. And if you want to share these root keys, the application session key, network session key, please share it. Share those security keys in a very secure way, okay? So as a manufacturer, we recommend you can try the joint server. That's the joint server. Is a dedicated server for handling the activation part on the LoRaWAN network. So the network servers, they contact with the joint server for activating the end device. And the joint server authenticates the network server and double check whether the device owner really wants to activate the end device on that network server. Well, the joint server will generate the session keys and sends these session keys securely to the network server and application server through the internet. And nowadays, the network server and the joint server, mostly they are integrated by the network server providers. So if you want to control, or if you want to bring your own joint server, please double check with your network operator or service provider if you have that choice, if you can use your own joint server. And some other security features. We can send the mark comments to check if the link quality is okay or not, because the end device will understand. He will know if he still survive, if he is still alive in this network. Otherwise, if the end device already lost the connection with the network, well, he will stop sending the message. He will stop sending the uplinks, but go back to the activation procedure to join a different network or asking to join the network again, so they don't get lost. Your packets, your payload packets, your data packets will not be lost. And with the acknowledge message, the data message confirmation, then you can know from the network that an uplink message, downlink message has been received or not. And the adaptive data race ADR mechanism, that is actually also a security feature because it can reduce the packet loss, and having a high packet loss can actually lead to the security issues. And because we are working with a radio protocol, anyone will be able to capture, anyone will be able to store the messages. Without the application session key, it's not possible to read the payload. So because the payload, they are encrypted already. And without the network session key, it's not possible to tamper with the payloads. But it is still possible to transmit the message again and again. It's called replay attacks. So please always enable the frame counter. It will check in the network server to prevent this kind of replay attacks. Some hackers always send you the join request again, time by time, again and again. So in order to get something from that. And this frame counter can help you to avoid these replay attacks. And the frame counters will figure out the message has been received already, and frame counter will not, the network server will not process it again. And finally, there are numbers that can only be used once for the security of the joint procedure when activating the end device. So every joint procedure is unique. So because of such nonce, that number can be used only once. And once the session keys, if unfortunately the session keys are compromised, security will be ineffective. And this is the case in any IoT system. not only limited to LoRaWAN. So here are some other very good practice. Use the OTAA provisioning when the keys, when the certificates are dynamically negotiated between an end device and the network and application server for each session. And force the network rejoin the device periodically to change the session keys. And maybe after several months, the network can ask the end device to rejoin, to start to send a join request again. And in order to change the application session key and network session key. And if using ABP mode, if you have no other choice, but you must use ABP mode, okay, make the session keys unique to each device because the session keys, they are pre-programmed in the end devices. So we must use them unique. Not all the devices use just the same session keys. Okay, if one session keys gets promised, the other session keys, the other units products are still safe. And use a secure hardware element in an end device to store the security credentials. So this will make it very hard to guess the session keys. Sometimes some advanced user or engineers, they would like hackers. They are very good at scanning the device memory so as to guess out your session keys. And additionally, use the secure boot to ensure that integrity of the end device firmware. And you can also use your own private network server or the application server with your own gateways to prevent unauthorized access at cloud level. So you can build up your private network. For example, taking use of multi-site gateway coming with the embedded network server inside. So everything is internally communicated. And finally, make sure that a trusted third-party network server and joint server that doesn't lock your device into a certain ecosystem. Well, so if you don't want to use our embedded network service, you can please choose the trustable brand. Otherwise, maybe your end device may locked in just one LoRaWAN network, and if you want to change it, it's very troublesome. Well, if you follow up this best practice, you can build up a system that is very hard to attack. And there are a few optimizations that you can do as well. First, your end device, the end device must comply with the LoRaWAN specifications. So you can purchase those end devices that are certified by LoRa Alliance already. And please don't send in many join requests at one time. So every 10 seconds, sending a join request, lower the battery quickly. But in that case, you can use a back-off mechanism. And interval is very important between the message should be in the range of several minutes. Or maybe you can smart with your data. You could, for example, transmit every 5 minutes, or you could only transmit when your sensor value changed more than or against your certain threshold. So if you predefined the conditions, well, if everything is fine, if everything is within that range, well, you can save the trouble. You can save your battery life to stop to sleep, or maybe only when the end device is triggered by motion or by other event. In that case, to send a message. Otherwise, just in sleep. And it's also very good to make sure that message is as small as possible because the short message have a shorter transmission time. That is always better for your battery life. And also it's very good for the overall network capacity. If you want to add more gateways, add more end sensors to extend the whole network quantity, well, that's very good for setting up different frequency of transmission. And finally, you need to be prepared for the package loss. Please keep in mind that most applications, they are sending data from distributed sensor to the cloud, not for controlling your ATM machines or the cash dispensers. So please make sure that your solution can still work, even if your loss may be several messages of the total solution. It can still work. So expect the packet loss. That's very packet loss can be affordable into your solution, and your solution performance will not be influenced because of that. And also, please make sure that you don't synchronize all the devices so that they don't send all the message at the same time. And sometimes you can use some random jitter or some random time to sleep. And as I said, the back-off mechanism. So if you cannot join a network, you can try again with the short interval, but maybe after some time, retry only every day or every 6 hours or so. So at first time, if your end device join a network, you can try to send a join request about 5 seconds, 10 seconds to make a try. But if the end device failed to join that network, well, please stop and retry it after hours later. And also, if your device is not moving but is fixed on a certain location, it's always better to enable the adaptive data rate. So the network will figure out what is the best data rate for your end device. Depending on the signal-to-noise ratio, he can figure out what's the best spreading factor for you. And if there's a link loss, please check it only after some time, after missing, for example, 3 acknowledgements, not after missing the first one. Okay, then do something after several times about the acknowledgement, message missing. Okay, let's see the end device. Why we say the LoRaWAN end devices, they are so good choice for the solution provider, for the system integrator, or for the LoRaWAN device designers, because they are so easy to operate. As we mentioned, the Class A, Class B, and the Class C type of class, you can mix them. You can mix to use them in the same solution, and all of them are using very small power, comparing to other technologies like NB-IoT. Well, and also you can choose the suitable spreading factor and the data rate to set up, and you can mix and match whatever you need. And that versatility and flexibility make the LoRaWAN really a good choice for solution providers. And you can mix different brands of the LoRaWAN end devices in a solution. They can be worked simultaneously. And from our site, you can find those different types of sensors with different functions, and those controllers as well. For example, if you want to build up a smart office, you can choose the temperature and humidity sensor, especially during this COVID-19 pandemic period, and the ambience, the indoor air quality is so important, especially in the inside. And if you want to build up, if you want to monitor the door and the window security, you can use the magnetic contact switch sensor. And if you have a tea room, the restroom in your office, maybe you may worried about the water leakage. So you can take use of our water leak detection sensors. and ambience monitoring sensors, of course, for the light, for the PIR motion, for the TVOC, the total volatile organic compounds, and carbon dioxide, and the barometric pressure monitoring. And finally, you can choose our controller with the digital input-output interface to realize the automatic control of the light, such as turn on, turn off, and window or the door open or close, or the HVAC, your air conditioning system, to turn on and turn off through this remote I/O controller. So here you can find there are very rich product line in our portfolio. And the same goes for gateway here. There are many different types of gateways in the market. You can either find lower than 100 euros, or you can find even more than $1,000 gateway in the market according to the functionality, such as the software that runs on the gateway and how many channels that they can listen to simultaneously, and how to manage those kind of gateways remotely, because the gateways is always deployed on a top place, on the top of building, on the roof of our office, or on the hill of the hill mountain, the mountain top. So in that case, it's very important to find a way to remote access into the gateway for the software upgrading or the setting change. And how the gateway, they work with the network server or the joint server with the third parties products, and if they have a cellular backhaul to support like 3G, 4G, and Wi-Fi, and how they can get powered on. So all those kind of factors we need to evaluate. We need to double check when we evaluating a gateway. And in MileSight, we have taken all these factors into our consideration when we design our gateway. So you can either find this indoor version or outdoor version at most competitive price. And also you can save time and trouble to work directly with our embedded network server and joint server if you just need one unit of the gateway in a project. And besides that, you can also take use of our basic station feature in the gateway. So take use one gateway as the master to manage other gateways, to manage other network server in other gateways. So if in case you need multiple gateways in one project. And also you can work out gateways with other very famous network service products such as TTN, LoRaWAN, AWS IoT Core, and ChopStack. And also you can get like 8 channels or maximum 16 channels to build up your own private network or public LoRaWAN network. And that high capacity can support suggested 2,000 sensor nodes, by one gateway. And here is the starter kit that's specially designed for the smart agriculture users. With this kit, you can find 3 different types of LoRaWAN sensors and 1 remote I/O controller with digital input-output interface, and indoor version gateway with Wi-Fi and GSM. So you can support the cellular. You can get one SIM card inside, so you can connect with the network server or application server through a very secure IP connection. And MileSight Cloud, that's our application server, application service, so you can enjoy the advanced features at free cost for 12 months. So you can get the you can download MileSight Cloud from the Google Play App Store to enjoy the app version or the web GUI version. And if you are worried about to store your data on the cloud, well, our My Site Cloud is hosted by AWS, Amazon Web Services. And in the world, we have 3 different servers. One is in Germany, one is in Singapore, and the last one is in mainland of China. So you can choose which place, in which place to store your data on cloud so safely. Okay, that's all I want to share with you guys today. If you have any question, please email us. So see you next time. Bye bye.